Hello everyone, welcome to the last task of week 7 in this chapter where we have covered while and do while loop. In this task, we are asked to find whether they entered, we have to print all the strong numbers within a range of numbers. Okay, so user is going to enter two numbers. Okay, and in between those two numbers we have to find all the numbers which are strong numbers. We have to only print those numbers which are strong numbers, and the second thing to note is we have to do it with the help of do while loop. Okay, so very important, as soon as you get the aim you should find out what all things is important. Okay, so first of all you have to find the strong numbers. Second, it has to be within a range of numbers. Okay, and third, you have to use a do while loop. Okay, now before we start, let's see what are strong numbers. Okay, so strong numbers are nothing but any number if we separate out the digits. Okay, and if we take the factorial of those digits and add them up, if it if it equals to the number itself, then we call it as a strong number. Okay, so you can see over here, for example 145, then if we do 1 factorial plus 4 factorial plus 5 factorial and we add them up, we get 145. Okay, so that means the original number and the addition of the factorials are the same. That means it is a strong number. Okay, so what we have to do over here in this program is the user is going to enter two numbers. Okay, let's suppose the user says I want all the strong numbers between 50 and 100. Okay, so you're going to run your program from 50 till 100, and you have to find out whether each which numbers are strong numbers and print them out. Okay, so let us try to code this. So to begin with, first of all, we can start with declaring the variables that we require, right? So we want a start variable and the end variable, right? So where we are going to store the start and end of the sequence. So this will be entered by the user, right? After this, we want to have the for loop, right? So sorry, for the do while loop there will be some counter variables, right? But that we will see a little later, right? So as and when we require it, we will declare it. Okay, so next step, just start with printf statement, just letting the users know what this program does, right? So strong number finder, right? And after this I can take the input from the user, right? Let's do a scanf, and we can do scanf we can take the interval from the user, right? That is, the first scan percentage d will be for the start and the second one will be for the end, right? So we can take both the values at the same scanf. So I will have start and end, and don't forget to add the ampersand sign. Okay, so once we add the ampersand sign, now it's ready to take the input, but it will be a good practice to let the user know what they have to enter, right? So enter the start and end numbers, right? And I can just give them a hint that they have to give in comma separated form, right? And once this is done, my input part is done. Okay, so next, before we continue, we should understand that we have to use do while loop, right? So let's declare a do while. Okay, so do while loop is ready. Now the stop condition, we will it's actually very simple, right? So the stop condition is So we have to have a counter. Okay, so basically it will be the number that is going to be there, right? So let's call it as number. Okay, so we declare a variable called number. Now this number is going to change, it is going to range from the start value till the end value. Okay, so if the user enters, let's say, start as 5 and end as 10, so the number will change from iteration to iteration. Okay, so in the first iteration the number will be 5, then 6, 7, 8, and it will go up till 10. Okay, so this number will be what that is the use of this number. Okay, so now it has to start from the number value has to start from the start variable, right? So I have to assign this number equal to start. Okay, so my range will start from this value. Okay, then it will go inside this do while loop, right? And it will do some operations, and at the end of the operation I have to increment the value of that num. Okay, so I will just do num plus plus. Okay, and then over here I just have to check if that num is greater than the end. Okay, it should not be greater than, sorry, if it is less than or equal to end. Okay, so always remember, you whenever you give condition inside any of the loops, whether it is while loop or whether it is for loop or do while loop. Okay, so you should always you should always put the condition for which the loop will run. Okay, so I want the loop to run whenever the num value is less than the end. Okay, so whenever it is greater than end it should break. Okay, so always remember this. So once this is out of the way, so now we are ready to write the logic for the strong number. Okay, so to write the logic of the strong number, we can since we have the number over here, so what we have to do is, first of all, we have to separate out the digits. Okay, now to separate out the digits, we have to have a another loop. We have seen in the last task, and even in the task before that, how to separate out the digits. Okay, so to separate out the digits you need to use percentage 10, modulus 10 and divide by 10. Okay, so for that you will be requiring two variables, right? So let's take those two variables. Okay, so let's say you have last digit and remaining digit. Okay, so you have these two variables. Okay, now here you start with a, you can start with any loop. Let's start with since we are asked to do it with do while loop, we will use do while loop, right? So do, and inside this I will just write while. Okay, so this program actually should have been done with the help of functions. Okay, so that the logic of the Armstrong number would have been written inside functions. Okay, but since this is this has come before even starting the function, so we will not use functions and we will directly write this inside the nested. We will directly write this inside the nested while loop. Okay, so do while loop. So let's begin. The logic is the same. Okay, so before we start we will just use as in the previous task we have done, we will just replace the initial value of remaining digits by num. Okay, whatever is the number, then we will come inside, and inside we will find the last digit. So last digit is actually remaining digits mod 10, right? And then we will calculate the new remaining digits with the help of divide by 10. Okay, so now our first task is done, right? That means separate out the digits. So the digits are in this particular variable, last digits. So once we have the digits, we need to find the factorial of it, right? So now to find the factorial of it, we have to have another for loop or a do while loop or a while loop, right? So we need to have another loop over here, right? So we will start another loop. You can see how complicated this program is going to become if we do not use functions. Okay, so this problem we will try to do it with functions also, and at that time you will realize the actual importance of using the functions and how simple it becomes. Okay, so right now the first do while loop is handling the range, right? So it is going to get the numbers from start to end. Then the second do while loop is to separate out the digits of the numbers, and the third do while loop is to find the factorial. Okay, so in both the cases I have not yet written what is the stop condition, right? So that we will do it as soon as we finish the inner loop, right? We already know what is the stop condition for this loop, right? So for this loop it is this remaining digits, it should not be equal to 0. Okay, since I have explained you in the last task why this is the case, right? And let's find out now in this over here we have to find out the factorial, right? Now to find out the factorial, what we have to do is we have to have a variable which is going to give you the value for the factorial, and we initialize it with 1. Okay, the reason why we initialize factorial with 1 is because it is a multiplication, right? So if we initialize with 1, if we initialize with 0, if I multiply anything with 0, everything will become 0. Okay, so that's why the starting value, whenever it's multiplication, it should be 1, and wherever it is addition, it should be 0. Okay, so we will see both of them because we are going to use both the sum and factorial over here, right? So let's find out the factorial first. So the factorial is actually, the formula is factorial is equal to, so current whatever is the value of the factorial into the counter value. Okay, so the counter value is going to be whatever is the last digit. Okay, so let's take the last digit. Okay, and in multiply it with the factorial, and in the next iteration the last digit should decrement by 1. If you remember the definition of factorial of 4, okay, factorial of 4 is nothing but 4 into 3 into 2 into 1, right? So that is how it is going to work, right? So in this case factorial we are starting with 1, right? So forget about this, right? So last digit, whatever is the digit that we get over here. So let's say we take an example. Let's say num is 121. Okay, so the starting number is 121. So it comes over here. If we divide 121 by 10, what we get is 1. Okay, so modulus we get is 1. Okay, so last digit is 1. So in that case the factorial will be factorial, that is already 1, if you see over here, into last digit, that is 1. Okay, and then I'm going to decrement. Okay, so when I decrement, the next after 1 you get 0, right? So when it becomes 0, if I multiply 0 anything with if I multiply like this, then the entire value becomes 0. So that tells me that this is my stop condition. So the last digit should not be equal to 0. Okay, so if that is the case, then that means that is the stop condition. Okay, so let's take another example. Let's say 7. Okay, so 127. So when it comes over here, the last digit is 7, so it comes inside this do while loop. So here the factorial is 1. Okay, and when I start over here, the last digit is 7, right? Then it is decremented by 1 and it checks whether it is less than if it is equal to 0. So it is not, so now it will be multiplied by factorial, that is 7 into decremented value, that is 6. Then it will be decremented again, right? That means this, now it will become 5. So in the next iteration it will be 7 into 6 into 5, right? So on it will go up till 1, and whenever it becomes 0, the loop will stop. Okay, so now one more thing to note is, now since factorial we are giving it over here, okay, so it will work for the first digit, let's say for 7, right? When it comes to the second digit, that is the 2, right? So what happens is, now the last value of factorial will be used to calculate the next digits factorial, right? So that will be wrong. So for that, what we will do is, whenever we enter the do while loop, so just before entering the do while loop, we will just make factorial back to 1. Okay, so this step is very important, otherwise you will not get the correct result. Okay, so once we get that, we have the things ready, right? That means we are finding the factorial over here. Now our next step is, so we have got the number, right? We have separated the digits one by one. So I have got the factorial of the last digit. Let's suppose if it's 145, then I've got the factorial, that is 120 I have got, right? Now I'm going to find the factorial of the next digit, right? So when that happens, it should not remove the whatever I have counted, right? So I have to store this somewhere. To store that, I will have another value, I will call it as sum. Okay, so this is the value that I'm going to check with num. Okay, so this num and this sum should be, if it is equal, then it's a strong number, right? So since it's a sum, I will initialize it with 0, and once this do while finishes, I will calculate the sum. Okay, sum is nothing but sum plus the fact, okay, whatever is the factorial, right? So this keeps on calculating the sum, and after all the digits are done, like for example in 127, case of 127, 7 factorial will be calculated with this loop, right? And then that factorial will be added into sum, then 2 factorial will be calculated with this loop, then that will be added to sum, and then 1 factorial will be added to the loop, and that will be added to sum. Okay, so once I get this, once I get the complete sum, so that means all the digits are over, so this particular loop is done. Okay, so once this particular loop is done, I will just check if num is equal to sum. If this is the case, then I will simply print %d and the value of num. That means this number is a strong number. Okay, so I will just print this, and after that I will check for the next number, right, in the range. Okay, now there is one problem over here, that when I check for the next number, now the sum is not equal to 0, right? Because I have checked for a number, right? And when I change the number, now the number will be incremented by 1, right? So when I change that number, this sum has to be reinitialized to 0, otherwise it will take the previous value of sum and do the calculation again, right? The same way we did factorial reinitialization of the factorial, the same way I have to reinitialize sum also. Okay, so whenever I enter the loop, okay, so I will put sum is equal to 0. Okay, so now I think it's ready. Let's see if we need anything else. Let's try to run it. So let's say between 100 to 200 I want all the numbers, and it's trying to run and seems like it has been stuck. Okay, so there is some mistake. Let's find out what that mistake is. Okay, so after a bit of observation, I have found out that in this program it's not able to it works perfectly for the numbers. Like for example, if I take 145 to 146, you can see it prints 145, which is the strong number, right? And it doesn't print 146. Okay, in fact, if I want, I can start 141 to 149, and if I enter, it still finds me, it only prints the number which is the strong number. Okay, so it works. But the problem here is it is not working for let's say if I add 140 to 150. Okay, so it's not working when I run when I put this 140 to 150. The reason is it is not able to find the value of 0 factorial. Okay, so you can see over here then the last digit, or if any of the digits is 0. Okay, so it is, this program currently is not able not handling 0 factorial properly. Okay, so for example, let's say the last digit is 0, so it will be 1. So this value will be, factorial is initialized to 1 into last digit is 0, right? So if I multiply this, I get the factorial as 0. Okay, and when I come over here, I decrement it by one value, right? That means now it will become -1, and if you see, it is never becoming 0. Okay, so that means this will never stop. So this goes into an infinite loop. So to avoid this, what we can do is we can simply check if the value, that is the last digit, if it is equal to 0. Okay, if it is equal to 0, then we can simply break the loop, right? So I can simply break the this particular loop, and so the value of the factorial remains 1 and 0 factorial is 1, right? So that means the program will work perfectly. Okay, so let's run it again. So let's take from 100 to 200. We can see there is only one number, 145. Okay, let's try some other range. Let's try from 1 to 1000. How many numbers are there? Okay, so basically there are just 3 numbers, 1, 2 and 145. Okay, so forget about the first two. 145 is the number, right? Let's try just out of curiosity, let's try a higher range. Let's take it. So it took a lot of iterations, and in such a huge number also there are only 2 numbers which are strong numbers. Okay, so 145 and 40585. Okay, so I hope you understood this pretty complicated problem. Okay, so this may be a little bit difficult to understand. That is because this is not the optimal way of writing this program. This program is it can be written in a very good manner with the help of functions. Okay, so in the next week we will be dealing with functions. There I will show you how to rewrite this program with the help of functions. Okay, so see you in the next week.